class. It's good to see you all today. Matt, glad to see you here on time. Guessing you drove today, not your brother. Okay. Today we're going to talk about variations of functions. Specifically, we're going to look at solving problems using direct, inverse, joint, and combined variation. So an example is gravity. Gravity is actually jointly proportional, or varies jointly with the time that it takes to fall and the time that it takes to fall. So if I was to drop this from here, it's going to take, say it takes X minute or seconds to hit the ground, right? Now if I was to drop this up here, from up here, it would take longer. That's what we mean by varies directly. The larger this variable is, the larger our answer is. So if our answer is the amount of, the distance that it falls, then the longer it takes, the farther it falls. So that's what we're talking about when I talk about varying directly. And we'll get more into that as we go on. So first off, let's look at some things that we should already know how to do. So we have this equation, lambda equals k times v. Can we solve for k? Can we solve for v? Well, right here, if we just go ahead and divide by v, that's going to give us our k by itself, right? So we're going to get k equals lambda. If we want to find v by itself, if we were looking for just v, we could divide by k. Right? So that's going to give us our v by itself, and v equals lambda over k. So even without any numbers or variables in there, we can solve for lambda, and we can solve for k. Right? Now, if we add some numbers in here, so let's say lambda equals 60 and v equals 15. Can we solve for k? If you want, you can start over here again, right? We could say, well, lambda equals 60 equals, v equals 15, and we're looking for k. So we just divide by 15, we divide by 15, and we get k equals, 4. Okay. Now, what if k equals 4 and v equals 3? Can we solve for lambda? Now, if we do start, we're going to want to start here, because we already have lambda equals k times v. So lambda is just going to equal 4 times 3, which equals 12. So k equals 4, and lambda equals 12. Now let's look at this one. Now we're starting off with a division. This is representing our inverse variation. As w gets bigger, d is actually going to get smaller, right? Because if we have, what's bigger? 1 over 10 or 1 over 100? So if we take one pizza, and we cut it into 10 pieces, or we take one pizza and we cut it into 100 pieces, which one's going to have the bigger pieces? This one. So as the number of pieces we cut it into grows, the actual size of the pizzas gets smaller. That's what we're talking about with an inverse relationship. And just like with direct, we can solve for k, or we can solve for w. So if we want to solve for k, we're going to take our k over w and multiply times w. We're going to take our d and multiply it by w, and k is going to equal d times w. Now, if we wanted to solve for w, we still have to multiply times w, because we've got to get this to the other side, because it's in the denominator now. So if we multiply times w, we get k equals w times d, but we're trying to get the w by itself, so remember, we divide by d, we get w equals k over d. So we're able, again, to solve for each of our variables. We get k equals d times w, or w equals k times d. I'm just showing you, we can, if we know this and this, we can solve for k. If we know k and w, we can get d. If we know k and d, we can get w. As long as we have two of these variables, we can find out the third one. So if now we have d equals 3 and w equals 20, we can plug it back in here, or we can look at this. We've already solved for k here, so we can say k equals the capital D, which is a 3, times the little w, which is 20, so k equals 60. If we have numbers for, now if k equals 60 and w equals 12, what's d? So we're taking d equals k equals 60 divided by 12, and we're going to get 5. Okay. Looks like we did it right. Good job, everybody. Okay. Now, this one is combined. It's directly, p is directly, varies directly with d, but inversely with t, right? We've got k times d, we also got k divided by t. Again, we can solve for k. Times d over t. If you want to solve for, make the d over t go away, we're just going to multiply times the inverse on both sides, right? Now our t's go away, our d goes away, and we have k equals p times t over d. Now if we wanted to solve for t, just like we did with our other inverse problem, we've still got to multiply everything times t, because we have to get our t on top, and then we're going to have to divide by p. So t equals k times d divided by p. And of course, just like the others, if we start adding in numbers, we can solve. If we have p equals 147, d equals 500, and t equals 50, we can solve for k. Once we know what k is, so if we know that k equals 14.7, and d is 700, and t is 12, we've got k, we've got d, and we've got t, we can solve for p. Okay. So what does this mean? Let's look at these. We just had a kind of a primer on these types of equations, right? As long as we have two of the variables, we can solve for the third. If we here we need 1, 2, we need 3 variables, and we can solve for the third. Notice that all of these equations had a k in it. K is considered our constant of variation. That means that these are our variables. They're changing. As v gets bigger, lambda gets bigger. As w gets smaller, d is going to get bigger. As w gets bigger, d is going to get smaller. Combined variation, this p is directly varies with d, but it's inversely varies with t. Now, once we find this k, it's not going to change. Our k is our constant of variation. These are varying, k is our constant. So, once we find out what k is, it's going to be the same for all of these problems. So it's kind of like God. How God is involved. He's always involved, and he's not changing. So there's always the God factor that doesn't vary. So k is our constant of variation. Once we find k in a problem, it will not change. It is constant. James 1:17 says, every good and perfect gift is from above, coming down from the Father of heavenly lights, who does not change like shifting shadows. Do not write God out of the equation. Okay, now we talked about gravity. The distance h that an object falls varies directly with the square of the time t it takes to hit the ground. Now this is our word problem. We don't know what k is. When we see varies, the object varies directly, we're thinking equals, right? Equals k times something. Varies directly means equals k times something. For us, our k is gravity. When we're talking about a falling object, our constant is gravity. As long as we're on Earth, our gravity is the same. So, looking at direct variation, again, varies directly means k times. So if k is 4, it's not changing. So if lambda equals 4, or if v equals 1, 1 times 4 is 4. 2 times 4, right? You can see as v increases, so does lambda. Because k is constant, and those are the things that are changing. Another way to say direct variation is they might say that it varies directly or is directly proportional. You can see that the ratio between these two, between these, is always the same. So when our v goes from 1 to 2, it's a difference of a ratio of 1/2. 2 over 1 is 1/2. 8 over 4 is 1/2. The ratio is the same. 3 over 2 is 2/3. 12 over 8, or 8 over 12 is going to give us 2/3. The ratio is the same. 3 over 4 is 3/4. 12 over 8, 12 over 16 is 3/4. The ratio is the same. So if it's direct variation varies directly, first is one variable increases, the other increases, and they're increased by the same proportion. So that's what we mean by direct variation. Inverse variation, or varies inversely, or inversely proportional, you can see as here our W, as it gets bigger, these are getting smaller. So here, 1 to 2, it decreases by half, 60 to 30. It decreases, or 1 to 2, it gets bigger, 2 to 1 is 1/2, 30 to 60 is 2. So this one, this is a decrease of 1/2, this is a change of 2. This from 3 to 2, or from 2 to 3, that's a change of 2/3. From 30 to 20, that's a change of 3/2. 3 to 4 is 3/4. 20 to 15 is 4/3. So you can see that the ratio now is flipped. It's as this one increases, this one decreases. This one, and they change at inverse ratios. So 2/3 becomes 3/2. 3/4 becomes 4/3. So as W increases, D decreases by the inverse proportion. So that's what we mean by inverse variation. Joint variation, or varies jointly, or jointly proportional. That just means that it varies directly with 2 or more other variable values. So if Y varies jointly with X and Z, Y equals K times X or K times Z. So it varies directly with X and it varies directly with Z. Combined variation, that just means it's a direct variation and an inverse variation. So it's Y varies directly with X because it's K times X, but inversely with Z because it's K divided by Z. So the distance an object falls varies directly with the square of the time it takes to hit the ground. So h equals g times t squared. That means if I was to take this object, this marker, and I knew that this was, we'll say that's 5 feet off the ground, and I was to drop it and time it. So if I know my height is 5 foot, and I drop it, and I know how long it takes, I can find out what gravity is. Okay? And if I found out what that g was, so if I drop this one from 5 foot, now if I drop this one from 3 foot, my g is still going to be the same. If I drop it from 8 foot, my g is still going to be the same because it's my constant of variation. So the next thing we have to do, we have to translate from English to math. So the wavelength lambda of a wave of a certain frequency varies directly as the velocity v of the wave. So that's telling us, that right there, that's telling us our general equation. That first part tells us our very general equation. Lambda, the wavelength lambda, varies directly. So lambda equals k times something. Now what does it vary directly with? It varies directly with the velocity v. So the first thing we want to do is we want to write our general equation. Lambda equals k times v. The next thing they're going to do is they're going to give us some information so that we can solve for k, for our constant. So they tell us that when lambda equals 60, then v equals 15 feet per second. So that gives us enough information to solve for k. So when we divide by 15, we're going to get k equals 4 seconds. And we got that from slide 2 earlier. Now we can solve the problem. Now they say, find lambda when v equals 3 foot. So we're trying to find lambda. We know that v is 3 feet, and we've already solved for k. We already solved that k equals 4. That means lambda is going to equal 12, which is exactly what we got on slide 2. Now, important thing with word problems is don't forget your unit labels. Right here. We're not talking about 12 bunnies, 12 fruits, 12 apples, 12 minutes. We're talking about 12 feet. So when we're doing word problems, we're talking about something specific. So be careful not to lose your unit labels. Looks like it's the end of my slideshow. That's pretty much everything I've got. We've got a few more minutes left in class. So go ahead and start working on the assignment for today. I'm just going to walk around. I'll answer any of your questions. Remember, we're looking for direct variations, which is k times, inverse, which is k divided by, and combined, which is k times and divided by. So, all right, well, let's get to work.